Let us understand how the speeds or velocities of the images behave vis-a-vis a mirror. So the rule is this: parallel to the mirror, the velocity of image is going to be the same as the velocity of the object. Okay, so let us say the object is moving like this. Then in that case, the image will also move simultaneously like so. So when the object moves here, the image has moved here. Then when the object moves here, the image has moved here, and so on and so forth. So object speed is going to be the same as image speed parallel to the mirror, or the component of the velocity of object parallel to the mirror is going to be the same as the component of velocity of image parallel to the mirror. Now let us see what happens perpendicular to the mirror. So let us say if this is a mirror, if the object is, let's say, approaching a mirror, then the image will also be approaching the mirror from the other side. Now let us say the velocity of the object is 5 minus I cap. So the velocity of the image is going to be 5 plus I cap. So that means that the velocity perpendicular to the mirror reverses. So let us make these observations. Velocity of the object parallel to the mirror remains the same as velocity of the image parallel to the mirror. Perpendicular to the mirror, what happens? Velocity reverses sign. Velocity of the object here, now this is very important, so I am writing it down mathematically. Velocity of the object with respect to the mirror. So here in this example we are assuming that this particular mirror is stationary. We'll see later what happens if the mirror is moving. So as of now, to write it accurately, I have to write down velocity of the object with respect to the mirror is equal to negative of velocity of image with respect to the mirror. So these velocities are in the perpendicular direction, perpendicular with respect to the mirror. Alright. Now what happens to the trajectory? Okay, so the trajectory is reflected in the mirror. So let us say if this is a projectile, or rather this is a projectile that was thrown like so, then the image of the projectile will be thrown like so. So if this is the angle of projection theta, the angle of projection from the image's side will be theta, like so. So herein we can understand that at every point, essentially, the perpendicular component and the parallel component. So this is the parallel component that I have drawn right now, and the perpendicular component. So both the parallel and the perpendicular components are going to follow these rules, these two rules that we have noted down over here. So the perpendicular component will reverse itself as long as the mirror is stationary. We'll see what happens when the mirror is not stationary, and the parallel component will be the same as the parallel component of the object. So the parallel component of the image will be the same as the parallel component of the object. Alright. So now let us look at an example wherein the mirror is also moving. Then in that case we simply need to take the perpendicular component with respect to the mirror. So let us say, let me give a velocity to the mirror of 2 I cap, let us say the object is approaching the mirror with a velocity of 5 minus I cap, or let us say minus 5 I cap, then what would be the velocity of the image? So herein what we have to do is we have to find out the velocity of the object with respect to the mirror. So velocity of object with respect to the mirror happens to be equal to velocity of, according to the principles of relative velocity, this happens to be velocity of object minus velocity of mirror. And mind you, these are vector quantities, so we have to now add or subtract them vectorially. So this is minus 5 I cap minus 2 I cap. So here we get minus 7 I cap. So this is what is going to reverse direction. That means we can directly write down velocity of image with respect to the mirror is going to be equal to minus 7 minus of minus 7 I cap, because it's going to reverse direction. So that means this is going to be equal to plus 7 I cap. Now this particular velocity, okay, let's write down velocity of image with respect to the mirror, as we saw, is plus 7 I cap. So that is velocity of image minus velocity of mirror according to the concept of relative velocity. This is plus 7 I cap. Therefore velocity of image is going to be equal to velocity of mirror plus 7 I cap. So velocity of image is going to be equal to 2 I cap plus 7 I cap, that is equal to 9 I cap in this particular instance. So let us say if the relative velocity of the image with respect to the object has been asked. Let us say velocity of image with respect to the object has been asked. Okay, so the velocity of image with respect to the object will be velocity of image minus velocity of object according to the concept of relative velocity. So this is going to be equal to the velocity of absolute velocity of the image with respect to the stationary ground frame. We know here is 9 I cap, we have just found it out. So 9 I cap minus the velocity of the object happens to be equal to minus 5 I cap. So this happens to be equal to 14 I cap. Now there is an interesting shortcut to find this out. Okay, so let's say we are the mirror, then the relative velocity of the image with respect to the object is going to be the same as if we are not moving with the mirror and we are stationary on the ground. So even if we were to be moving with respect to the mirror or we were to be stationary with respect to the ground, the object and the image are approaching each other at the same relative velocity. So we already know that velocity of image with respect to mirror is plus 7 I cap, and thus we also know that velocity of object with respect to mirror is minus 7 I cap. So if we just understand this, then we could have utilized these two equations to easily find out this answer. So we just have to essentially double it in magnitude. So let's see how that works. So we need to find out velocity of image with respect to object. Okay, so now we are understanding these two velocities to be with respect to the mirror, because as Einstein told all of us in 1905, what I said was velocity of image or velocity of object or velocity of mirror, all these velocities are still in the inertial frame of reference. So all inertial frames of reference are equivalent. So that means if I am taking the velocity of image, then if I take it with respect to the mirror or with respect to the ground, both the concepts are going to be equivalent. So velocity of image with respect to object can be said to be velocity of image with respect to mirror minus velocity of object with respect to mirror. According to the principles of relative velocity, the velocity of mirror is getting cancelled over here. So I leave that to the student to figure it out. expand these two and figure it out basically. So basically velocity of image with respect to the mirror is 7 I cap and velocity of object with respect to the mirror is minus 7 I cap. So this also gives us the neat and clean answer of 14 I cap. So if we do realize this fact, then if the velocity of object with respect to the image has been asked, in such a case we can easily write it down from these two rather than having to perform this particular calculation. For those students for whom this got a little complicated, then we can stick with the regular notion and the concept of relative velocity to find the relative velocity in this particular manner. So thus we understand object speed, image speed, object velocities and image velocities vis-a-vis a mirror.